Hello and good day, geometry. No, I've not forgotten about you. This is your hint video, your explanation video for math packet number 4, due December 1st. There's a stack of them on my desk at school. Pick one up at any time, or I've also posted one on Google Classroom that you can print out if you'd rather that. So here's your first logic question page. It says two rectangles have perimeters of 144 centimeters. So first of all, let's kind of review perimeter, right? That's if you add all the sides together. What is the greatest possible difference between their areas if the length and width of both rectangles are integers? Okay, so here's what we have. We've got rectangle A, rectangle B. How big I draw them doesn't really matter. You know, I'm going to be labeling sides here. And even they both look like they're the same size. If I label them different sides, then, you know, that's just how math works. This is just a sketch. So perimeters of 144 centimeters. So let's see. Let's say that, well, basically to get a perimeter of 144, two sides will have to add to equal 72, right? Because if two sides are 72 and being rectangles, you know, they're going to be opposite sides are congruent. 50 plus 50 plus 22 plus 22 gets us to 144. Let's try over here. Let's make this one, we'll make a 40, and that would be 32 then, and 40 and 32, and 40, 40, 32, and 32 equals 144. And so what we're really looking for here, though, the greatest possible difference between their areas, and the fact that the length and width are integers, I can rule out decimals, fractions. That kind of helps a little bit here. But the area of this first rectangle, 50 times 22, is 1,100. Pretty big. And 40 times 32 is 1,280, which is a difference of 180, right? Difference would be how far apart they are, or if you subtract them, we get 180. So let's see what happens here. I'm going to keep my second rectangle the same, and I'm going to redraw the first one. And instead of 50 and 22, I'm going to go 60 and 12. How does increasing that length from 50 to 60, how is that going to affect the area here? 60 times 12, that's 720 area, which is a bigger difference than I had with my 50-22. This difference here was only 180. This difference here between 1280 and 720 is 560. So it seems like increasing that length from 50 to 60 made the difference of their areas greater. And you're looking for the greatest possible difference. The greatest possible difference. Okay, so that's kind of how you want to approach this. Kind of play with the length and the width a little bit, see what happens, and then from there, kind of maybe form a conjecture. You know, if I do this, then this is going to happen, with your goal of getting that greatest possible difference. Don't forget to answer the "Why my answer makes sense" section here. Okay. I got to see the work or an explanation as to why you got the answer and why it makes sense. Next one. We've got, there are 15 people at a party. This is a classic logic question. It would not surprise me if you've heard this before or something similar to it. We've actually done something similar to this in a previous packet with those basketball games and how many games in a league in a season or whatever it was. But there are 15 people at a party, and they each shake hands with everyone else once. Not in 2020. How many handshakes are there all together? Count each handshake just one time. So for example, person number 1 shaking hands with number 2 is the same handshake. You only count it once, as person number 2 shaking hands with number 1. So you can kind of set this up like you did with the basketball games in a season, right? Person number 1 is going to shake hands with who? Person 2, person 3, person 4, person 5, 6, 7, 8, 9, 10, 11, 12, right, smaller than I did, 13, 14, and 15th person at the party. Okay? Then who is person 2 going to shake hands with? Well, We're not going to write 1 down here because person 1 shaking hands with 2 is the same as person 2 shaking hands with person 1. We don't want to count that twice. So we're going to start with person 3, 4, 5, 6, 7, dot, 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 dot. Okay. And once you start doing that, you're going to find a pattern, and you'll be able to use that pattern to predict ultimately how many handshakes are going to be taking place, and then how many people have to quarantine as a result of all this handshaking. Okay. All right. That is logic question 2. You can kind of tie it back to those basketball questions from before. 5-card challenge. You know how this works. You being in both geometry and algebra, you don't need to do this on your algebra packet page. Please do it on your geometry page so I know to look for it here. And then on your algebra packet, just please write, C geometry or whatever. You're going for 21 points, at least 1 5-card combo, and all the other rules still apply. Here we have the shaded area question. It says, calculate the percentage of the figure that is shaded. Show all of your work. This includes writing out every calculation. The dotted line represents the diameter of each circle. Okay, so we've got kind of this, yin-yang looking type thing here, but recognize we've got a lot of circles here, at least half circles, right? The whole figure is a large semicircle, right? And then a small semicircle here. And then you've got this medium-sized semicircle within that large figure, okay? So like we've talked about before, there is no formula to get the shaded area of this kind of, this, swooshy looking thing there. So what you want to do is find the area of the entire figure, which is the large half circle and the small half circle. And then from that, subtract the area of this unshaded, medium-sized half circle. Okay, so you've got 3 half circles of different sizes. The formula for the area of a circle, hopefully we're getting this down because we've used it very frequently. Pi r squared is the general formula for a circle. However, because you only want half of the circle, you'll be dividing this by 2. Okay, so the area of half circle is pi r squared divided by 2. All righty, next question, pattern blocks. We did talk about this in algebra. If you could actually complete the table in your algebra packet, it does, since that's your task for algebra, which is a little bit different than your geometry task. Your geometry task is to make that chart. It helps with my correcting if I'm not constantly flipping back and forth between your geometry and algebra packet, especially if you don't turn one of the packets in. Then, if I've got your algebra packet and a whole bunch of pages that says C geometry, if I don't have geometry, I can't really give you credit for it in your algebra packet either. So as much as you can in this case, please complete the table in your algebra packet. If you want to complete it again in the geometry packet, you certainly can. But otherwise, you just need the graph for this. Then we get to shaded area. Okay, it is the same as your algebra packet. So if you only want to do it here, that is okay. Yeah, for this one especially, it's a little more work than the pattern block question. But we already talked about it. Make sure that's 16 feet. That's the height of the triangle. It's not a diagonal side. So that's why that's important. Make sure you are drawing out the net and labeling each side if you want full credit for this one. Then volume. Don't answer both questions on the same page. This question should be answered in your algebra packet. And this one should be answered here. And this one says, the slant height, the height of a triangular face, is 8 inches for the triangle with a base of 10 and 7 inches for the triangle with a base of 8. So what this is saying is that, here, this dotted line that's going down from the top of the pyramid down to the base, that is the height of the pyramid, and that it's going straight down, like through the pyramid. If you're like drill a hole from the top down to the bottom. That's the path that it would take. We're talking here about slant height, which is kind of like that surface area. It's the height of that triangular face. Okay, if you were to roll a ball down the side of that pyramid, that's the path that it would take there, that slant height, the height of that triangular face. And it says 8 inches for a triangle with a base of 10. So this red slant height there is 8. And it is 6 inches, 7 inches for the triangle with a base of 8. So again, this height, not the diagonal side, the height of that triangle there is 7. And it says, what is the surface area of the pyramid? So similar to your last page as far as how to get the surface area, but in your last page, your base is a square. So all 4 triangles have the same area. For this one, since your base is a rectangle and you have 2 different triangle heights, you've got triangles of different sizes, you kind of have 2 of each there. So you have to think about it a little bit differently than you did in the surface area page. But needing those slant heights is important, and there you have them for that. All right. Next one, we have math exploration. We are talking about George Alexander Pick, who lived from 1859 to 1942. And what Mr. Pick did was when his math teacher told him to find the area of a polygon, such as this, on the coordinate plane, he got tired of dividing it into different sections and finding the area of this piece and that piece, maybe a rectangle here, a triangle there, these irregular figures. So he decided to come up with a conjecture that was eventually proven, became a theorem for how to find the area of a shape such as this. So I didn't print this in color, which is silly here, but it says first count the number of interior points, which we'll call I, in red. And the interior points are these points on the corners of these grid squares that are inside the polygon. Interior, inside. Okay. Looks like there are 1, 2, 3, 4, 5, 6, 7 of them. Okay. Then count the number of boundary points, points on the outside of the polygon, in green. It looks like there are 8 of them. Okay. So 8 boundary points, 7 interior points. And Pick's theorem is the area of this polygon will be, I shouldn't cross it out when I box it, that's, okay. The area is going to be the interior plus the boundary divided by 2 minus 1. Now, notice the order of operations here. You're only dividing the boundary points by 2. It's not the sum of I and B divided by 2. It is just B divided by 2, then add the interior, then subtract 1. So with the interior points, in our example here being 7, the boundary points being 8, our formula is this, right? The area is 7 plus 8 divided by 2 minus 1. 7 plus 4, which is what 8 divided by 2 is, right? 7 plus 4 is 11 minus 1 equals 10. The area of this polygon is 10. A lot faster than, trying to divide it up and take areas of this shape and that shape and whatever else. And so you've got some to practice here. This first one it's very easy to find the area. Just count up the squares. This is more of like a practice thing. Make sure you're doing it right. So the boundary points, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. The interior points, we have 1, 2, 3, 4, 5 of them. Okay, so our formula is the interior plus the boundary divided by 2 minus 1, or 5 plus 9 minus 1. 5 plus 9 minus 1 is 13. And if I count these squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, I see that the area is 13. So this theorem does work. The formula does work. And it really comes in handy when you've got some more, shall we say, interesting figures to work with. This, don't know what you call that, like a dilapidated barn arrow gone wrong, something. This sunburst is pretty fun there. And then this thing, I don't know, like a lightning bolt gone wrong. I don't know. Anyway, so use Pick's theorem to find the area of these polygons. Where we're talking about, you know, this is the polygon here, all this jagged thing throughout, so you got to find the interior, the boundary points, do all that stuff. Use Pick's theorem. Yay, Pick! Thank you. Okay, next one, we've got the possibility diagram again, where you've got an algebra and a geometry question. Do this question in your algebra packet, please, for correcting purposes. And then this question here goes, the answer is right there. You spin 2 spinners, each with 8 equally sized sections. So just like our algebra probability hint that we talked about, you've got 1, 2, 3, 4, 5, 6, 7, 8, right? And then 8 going up, 1, 2, 3, 5, 6, 7, 8, right? Using a possibility diagram, what is the probability of spinning the same number both times, a sum that is prime or a sum that is a perfect square? And you don't want to count the same outcome more than once. For example, you know, if you spin a 2 and a 2, the sum of that is 4. Well, that actually fits 2 conditions. The both are same number both times and a sum that is a perfect square. You don't want to count it twice. You only want to count it once, right? So just watch out for that, okay? And the last page is and just remember that probability is successful divided by total, right? So the number of successful outcomes divided by the total number of possible outcomes, which is where the possibility diagram really comes in handy, because it shows you what all the outcomes are, and you can count which ones are successful and then compare that to the total number of possible outcomes there. Lastly, we've got the Polyamino page. I don't know what explanation is needed here. Just remember, you know, use logic for this. There are certain places where certain figures just cannot be. You know, this one here, this one here, this one here, this one here, this one here. None of those can be in this stem area, right? So you can kind of use that to help you. You don't need to do this on your algebra packet, since it's the same thing, just a little bit extra. So if you do it here, in fact, you have to do it here. Even if you do it in your algebra packet, you still have to do it here also. But if you don't want to do it in algebra, just write C geometry, and that will count. All right, that is math packet number 4. It is due December 1st. It's on my desk for you to pick up at your leisure. Otherwise, post it in Google Classroom as well. If you have any questions, get a hold of me. You can turn in early for me to check over. Highly recommend that. That's all I got for you. That's how you math, folks. Have a great day, and best of luck with math packet number 4.